Now that we understand how Pascal's triangle works, let's actually apply it to expand the power binomial. So I have here x plus y to the 6. We'll start a little simple. And so if you have the 6th power, what that means is you want to look at, and I'm going to say the 6th row. Now you're going to have to be careful because the rows are based off the powers. And so this is row 0 because that's to the 0 power. This is row 1, this is row 2, this is row 3, 4, 5, and 6. To know which row you want to look for when I say 6th row, kind of look at the second term in the triangle. The 6th row now meaning I'm dealing with the coefficients of 1, 6, 15, 20, 15, 6, 1. And so let me highlight those. This is the row I want to work with. And what we're going to do now is we're going to expand this binomial. What happens is you take, I'm going to write down 1, I'm going to write down 6, I'm going to write down 15, 20, 15, 6, and 1. There are the coefficients, and these are going to be the terms. And what I'm going to do is I'm going to fill in my variables. The first one is x. And so I'm going to take x to the 6th. And we learned in the previous video that your exponents decrease by 1 each time. And so this is going to be x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and nothing here. And then what I do is take the second term, which is y, and I fill it in. Well, no y goes here, a y to the 1st goes here, a y squared goes here, and I increase. So 0, 1, 2, so this becomes y cubed, y to the 4th, y to the 5th, and y to the 6th. And I say since it's a plus sign, all of these are going to be plus signs. And there's your binomial expansion for it. So I work with the row first, then I deal with the first term, which was x, and I fill in, I want x to the 6th, and x to the 5th, and so on, and decrease by 1. And then I take the second term, which is y, and I increase the exponent by 1 each time. And so that is the binomial expansion of x plus y to the 6th power. Nothing too complicated, but we are going to look at ones that involve a little more thinking. So if we take example number 2, what's different about this is rather than just having x, I have a 2x. Rather than just having y, I now have a number, I have 5. And so we're going to look at how we can use Pascal's triangle to expand a binomial with coefficients and constants that aren't just variables. So if I take a look, 4th power means I want to look at the 4th row. So just look at the second term. So I see 2, 3, 4. So here's the row I want, 1, 4, 6, 4, 1. So again, I'm going to highlight it. Those are going to be my coefficients. A 1, a 4, a 6, a 4, and a 1. Now comes the part that's a little bit tricky for people to understand. Before, we just grabbed the x and threw it in with the power. Now, the reason why we did that was because that's all that was there was just x. But now I have a 2x. And so what that means is I have to take the 2x and throw it in with the 4th power. And then we decrease our power by 1 each time. So this would be 2x cubed, 2x squared, 2x to the 1st, so just 2x, and then I don't put it there. So you can see 4, 3, 2, 1, and it's not there. And the same goes with the 5. The 5 doesn't go here. Remember, your 5 starts at 0 and increases by 1 in the exponent. And so this would just be 5. This would be 5 squared. This would be 5 cubed. And here I would have 5 to the 4th. Notice I put whatever the term is in the parentheses and the exponent outside. It makes, one, order of operations easier. Two, it allows us to kind of help out with the calculator if we need to. And since this is a plus sign, they're all plus signs. And now, I mean, this is not simplified yet. We actually have to go one step further. We're going to have to expand the whole binomial, put it in standard form. So 2 to the 4th power is 16. So I have 16x to the 4th plus, and we can kind of do the math here. 2 cubed is 8, so I have 4 times 8x cubed times 5. And so that's going to give me 160 x cubed. And same idea, just go through and simplify. So I have 6, 2 squared is 4, so I have 4x squared. 5 squared is 25. I know 4 and 25 is 100, so 6 times 100 is 600. So I get 600 x squared. And I go through and finish again over here. I have 4 times 2x, and then 5 cubed is 125. And so I have to take 4 times 2 times 125. Well, I know 125 times 4 is 500, times 2 is going to be 1,000. So I have 1,000 x plus 1 times 5 to the 4th. Well, 5 to the 4th is 625. Anything times 1 is itself. So my final binomial expansion is 16x to the 4th plus 160x cubed plus 600x squared plus 1000x plus 625. So if you have an expression here, not just a variable, but a coefficient with it, it goes in a parentheses and the power applies to both the coefficient and the variable itself. So let's do one more. Let's look at number 3. Notice this one has a minus sign. So we're going to take that in consideration. I'll show you how when we expand. But the 5th power means I want to look at row 5. So I look down here. Here's row 5, 1, 5, 10, 10, 5, 1. And so let's go ahead and fill in those coefficients. So I have a 1. I have a 5, a 10, a 10, a 5, and a 1. And now let's focus on the terms. So here's the first one. It's 2x. So parentheses 2x. And I'm going to do the 5th power. And then that decreases each time. So 2x in a parentheses to the 4th power. 2x cubed. 2x squared. 2x to the 1st. And then nothing here. Now in the next one, let's go ahead. We didn't do it before because there's a plus sign, but since it's a minus sign, let's go ahead and use a negative value for it. And so what happens is we have a negative 3, which does not go here. So negative 3 to the 1st starts here. Negative 3 squared. And then you have negative 3 cubed. You have negative 3 to the 4th. And you have negative 3 to the 5th. And all of these right now, we said were plus signs. So I'm going to fill in the plus signs for us. Now comes the order of operations to simplify. 2x to the 5th power, well, 2 to the 5th is 32. So I have 32x to the 5th. Now order of operations tells me I'm going to have 5, 2 to the 4th is 16, and then negative 3. So I have 5 times 16, which is going to be 80, times negative 3, which is negative 240. So since it's negative, it becomes minus 240 x to the 4th. Same idea here. I'm going to have 10. 2 cubed is 8. Negative 3 squared is 9. So 9 and 8 is 72 times 10 is going to be 720. So since it's positive, I have a plus 720, and it would be x cubed. So notice now when I'm doing order of operations, I'm not worrying about the variable. I'm putting that in at the end. And so if I have 10, 2 squared is 4. Negative 3 cubed is negative 27. So I'm going to have 10 times 4, which is 40, times negative 27, which gives me negative 1,080. So that's minus 1,080, and it would be x squared. And I have 5 times 2, negative 3 to the 4th is an 81. So 5 times 2 is 10, times 81 is 810. And so it's positive, so plus 810x. And then last but not least, I have negative 3 to the 5th power, which is negative 243. And since it's negative, it's going to be a minus sign, so minus 243. And so that is the binomial expansion of 2x minus 3 to the 5th power. It's all based off plug in the term in a parentheses with following the patterns of the exponents, and then do your order of operations. In this example, compared to the others, I did not put the x in. I just did 2 to the 4th because I know it's going to go 5, 4, 3, 2, 1. And so I worry about the variables at the end. So I hope you find this helpful when it comes to expanding a binomial by using Pascal's triangle.